In 2025, we mark two remarkable centennials in science and technology. First, we celebrate the 100-year anniversary since Julius Edgar Lilienfeld proposed the concept of field effect transistor, FET, a foundational breakthrough that paved the way for modern electronics. Second, 2025 has been designated the International Year of Quantum Science and Technology, IYQ, commemorating a century since the birth of quantum mechanics, one of the most transformative scientific revolutions in history. These two milestones converge in a powerful way. Together, they enabled the invention of flash memory by Toshiba in 1980. Since then, flash memory has become central to nearly every kind of computing and storage. As data-intensive applications grow, so does the demand for faster, more reliable memory technologies. Leading the charge in innovation is Micronix International, led by President and Chief Technology Officer Chih-Yuan Li. Flash memory is built on billions, sometimes trillions of tiny components known as floating gate or charge-trapping transistors. Each of these transistors can trap or release some electric charges, which are stored between two precisely engineered insulating layers, forming a kind of dielectric box. These trapped charges determine whether the transistor is read as a 1 or a 0 in binary code, or as multi-bit data. Unlike volatile memory, which loses data when power is turned off, non-volatile flash memory retains its stored charges. This means the data remains intact even without power, making flash memory essential for long-term data storage in everything from smartphones to data centers. Over time, flash memory has evolved into many forms, each with its own strengths and weaknesses.
NOR flash and NAND flash are two main kinds of flash memory. NOR flash figures fast random access read and high reliability. It is most suitable for non-volatile storage of computing code. NAND flash figures high capacity and relatively slower read. It is used for non-volatile storage of high volume data.
The most obvious way to improve flash memory was to make its transistors smaller following the principles of Moore's law, so more fitted into a single chip. However, with the physical and electrical limits of scaling for reliable operation reached a decade ago, other ways of increasing capacity were needed. Micronix responded with invention, development and mass production of N-bit technology, a nitride-trapped non-volatile memory that set new standards in performance and reliability. Building on this success, Micronix went even further by inventing B-Sonos technology, which became the core technology for 3D NVM flash memories. This innovation has played a critical role in enabling higher density, more scalable memory solutions for the data-driven world.
The N-bit NVM cell is based on localized charge trapping in an ONO gate dielectric. When a standard N-bit NVM cell is operated in a 4-bit per cell mode, 2 bits of data are stored in each of its two separate storage areas. Micronix shipped more than 1 billion chips to a world-leading electronic gaming company for its most famous and popular computer game applications over 20 years.
In addition, Micronix also introduced self-annealing memory, a technology that allows chips to repair themselves, improving data resiliency and extending device lifespan.
The new kind of flash has a built-in self-annealing mechanism to counteract wear, thermal stress, and defects over time. It provides local heating to repair degradation at the chip level by applying heating pulse after extensive program erase cycles. Our prototype device showed more than 1 billion cycle endurance with on-chip self-healing. This promising technology is currently under active development. We foresee its being of great use in many areas such as automotive, aerospace, defense, and applications which are remote from replacement but demanding high resilience and longevity needs.
These innovations power the technologies we rely on every day, from mobile phones and AI to cloud and edge computing, shaping the future of computing. For innovations and leadership in advancing non-volatile semiconductor memory technologies, including cell density, device integration, and data resiliency, the 2025 Future Science Prize for Mathematics and Computer Science goes to Chih-Yuan Li.